Hello, in this video we will talk about duplexing in wireless communication. Duplexing in cellular system allows the two-way communication between the devices, that is from mobile user to the base station or from the base station to the mobile user. Or we can say it is the ability to simultaneously transmit the signals from the mobile and from the base station. If we consider an example, there is a base station here and the mobile user is present there. So when the mobile user is sending signal to the base station, this transmission is known as the uplink transmission, and the other transmission from the base station to the mobile user is known as the downlink transmission. So duplexing indicates the ability to simultaneously use the uplink transmission and the downlink transmission, either in different frequency or in different time. So there are two kinds of duplexing in cellular system. One is the frequency division duplexing and another is the time division duplexing. So in frequency division duplexing, both the uplink transmissions and the downlink transmission, they happen at different frequencies. For example, in GSM, if we talk about, the uplink band is allocated as 890 MHz to 915 MHz, and the downlink band is allocated as 935 MHz to 960 MHz. So the spacing in between the band is 25 MHz. So now if we consider another example, that this is the uplink transmission band and this is the frequency downlink transmission band. So if this band is used for this frequency is used for the uplink communication, the frequency that will be used in the downlink communication will be exactly 45 MHz apart. And why there is a spacing of 45 MHz in between the uplink and downlink transmission, and this spacing is always preserved? This is because of the following reason. Because the power level with which your mobile transmit is 1 watt, which is 30 dBm, and the received signal power that is coming from the base station is around minus 100 dBm because of the available noises in the signal. So if we plot this into the bar graph, we will get like this. So this is the uplink, that is 30 dBm, and the received signal, which is delay in frequency, is minus 110 dBm. So we can see that there is a huge gap between the two gains to the magnitudes, or we can say there is a difference of 130 dBm. So for that reason, we do not want uplink to affect the downlink, because uplink and downlink, they both use the same antenna. The circuitry are physically close to each other, and there is a possibility that there is a RF linkage from the uplink to the downlink. And if it is so, the downlink will be completely wiped off. To ensure that this may never happen, we introduce a band pass filter which behaves as a, if this is 915, 890 to 915 and 935 to 960, we introduce a band pass filter up to 950 it behaves as a stop band, and then after 935 it behaves as a pass band. So the filter is like this. This is 915 and this is 935. So that means it will allow all the frequencies that are greater than 935. And this is sitting right at the front of the transmitter and the receiver section. We call this filter as the duplex filter. The duplex filter makes sure that the RF chain is protected from the radiations that happening in the transmitter chain. So additionally, duplex filter has high Q, and this component is bulky. So therefore delta F is kept to 45 MHz to make sure that the Q factor of the duplex filter is manageable, and so that the component is not too large. So finally, the advantages in FDD is the duplex filter is the bulky component that protects you and prevent the RF chain from the transmitted chain. And we must need to be very careful in designing the duplex filter. The next is the time division duplexing. In time division duplexing, the uplink and the downlink, they are happening at the same time, they are happening at the same frequency but at different times. So now there was always a discussion about, so is there any way that we can use the advantages of time division duplexing and frequency division duplexing together? So GSM comes with a very clever approach. So the approach is like, we have this one time slot. So GSM has 8 time slots. So GSM has 8 time slots. So if we have uplink coming in the first time slot, the downlink will come offset in time. So that means there is an offset in time. Though they are using the different frequencies, but the time at which it transmits and receives are at different times. And due to this reason, we do not need a duplex filter here in the front end of the transmitter and the receiver, but we need a duplex switch. So otherwise, if we do not consider this offset in time, we need to consider the duplex filter always, and there is no other choice we have. So since voice communication do not have a duplex filter, because GSM has allowed us to use the advantages of time division duplexing and frequency division duplexing togetherly in a very good way. So if we talk about some other technologies, so for example, CDMA and 3G, they both use FDD duplexing, whereas the 4G uses TDD band. Now, it is very interesting to see why we have uplink before the downlink. In GSM, it is also like uplink first and downlink second. So why it is so? The simple reason is because the mobile user, if we consider mobile user and base station, the mobile user has a very low power. So the signal that is sent to the base station, the uplink signal, is more vulnerable because of the low power of the mobile device. Whereas the signal when transmitted from the base station to mobile user, that is downlink signal, is less vulnerable because the base station transmits with a very high power. So if we know the expression that the path loss is directly proportional to the frequency, carrier frequency, so the idea is to give lower frequency to the lower path loss. Since the downlink is more vulnerable, we will allocate low losses, that is low frequency, to the uplink and the high frequency to the downlink. So this is basically the simple reason why downlink is first and uplink is later. Why uplink is first and downlink is later. So next we will see the comparison between time division duplexing and frequency division duplexing. It is very interesting to see, if we are studying the time division duplexing and the frequency division duplexing, it is very interesting to see what are the comparison between the TDD and FDD, because we need to design some system at some point of time. So if we consider spectral efficiency, time division duplexing is more flexible because it dynamically allocates the same frequency band for uplink and downlink transmission and can be adjusted based on the traffic demand. So FDD is the fixed allocation of the resources for each direction. So that means it may not completely utilize the available spectrum and has a constant capacity. So interference, TDD, yes, interference is there because if traffic is unbalanced, then there might be chances of interference. Whereas in FDD, there is a better isolation because of the presence of duplex filter. So deployment flexibility, TDD is more suitable for asymmetric traffic patterns, particularly useful where there is a high data demand for downlink communication, example video streaming, whereas the FDD is more suitable for symmetrical traffic patterns, for example real-time bidirectional voice communications in GSM or 2G network. So complexity in time division duplexing, so since they are offset in time, we need some precise time synchronization methods to synchronize between the base station and the mobile user. Whereas in FDD, we have this complexity involved in terms of duplex filter. So now we have studied the TDD and FDD. So we reached to the conclusion. So the choice of selection of TDD and FDD is based on the system requirements of the applications. What are the applications? What is the available spectrum? What are the characterization of the traffic? So how we need to manage the traffic in between according to the application and according to the requirement of the mobile user. So these three factors shows us which scheme to use, either TDD or FDD. So nowadays, in recent years, we have this flexible framework called as dynamic spectrum sharing. So it dynamically allocate spectrum resources between the time division duplexing and frequency division duplexing based on the network conditions. So it also allows efficient spectrum usage and enhance the deployment flexibility of 5G network. When the word dynamically allocates, it comes, so we can obviously the spectrum efficiency is increased. That's all. Thank you.